Gary, program's yours.
All right. I'd mentioned a few months ago that I was going to donate B&A and a computer to the club, so someone suggested I ought to show how it worked before I donated. V&As are excellent for analyzing antennas, and I noticed a lot of new faces here this morning, and if they don't know who I am, I'm a retired microwave design engineer, RF design engineer, and I have a lot of times people ask me, where did you get started in electronics? I've been in it about 50 years or so, and if I tell you this story, that's the only thing you'll remember what I say today. But anyway, I really got interested in starting in electronics when I tried to electrocute my cousin. When I was ever since I can remember, I used to, when I was 10 or 12, I used to get these electronic magazines, and this was in the 50s, and I was reading one of the magazines, and there was a microphone you could get back then that you could just plug into your radio, and you'd be like karaoke, you know, you could talk in the microphone. Well, I ordered one of these, and I plugged it in, and my cousin and I, we were sitting around in the house, and he was talking. Well, if you're sitting in the same room with the guy, it's not very effective. So we lived out on an old farm, and so I said, well, go in the kitchen, and you can go out on the back porch, and you can talk on the microphone, and I'll listen to it on the radio. You'd be just like you're coming up with the radio. And so we took it in the kitchen. I set the radio on top of the thing, and he went out through the back door, and all of a sudden I heard all this noise and banging and carrying on and yelling and screaming. Well, this was an old farmhouse and had lightning arresters on it, led on top of it, and running down the side of the house had where the lightning rods was connected to the ground. Well, when he went out and started to set down, he reached over and grabbed a hold of the lightning rod ground, and when he did that, he got 120 volts, and he was pulling that thing off the wall and yelling and screaming and trying to get away from it. Well, back in those days, they didn't worry about getting sued or anything, and when they built those radios, they actually attached one side of the power line to the chassis, and the other went to the vacuum tube that rectified and created the DC to operate the radio. Well, if you plugged it in one way, the chassis was not hot. If you plugged it in the other way, there was no polarized plugs back then. They all AC plugs, you could just plug them in either way. Anyway, that started me to really looking into electronics and why in the world I shocked him. But
Was he ever the same again?
do what?
Was he ever the same again?
No, not really. He didn't trust me anymore either. But so that's how I wound up eventually becoming an engineer, and I'll try to keep my lecture. I remember when I was I always remember one thing about what a professor told me when I was in the college or University of Illinois. He said, never talk for more than 15 minutes, because if you're lecturing for more than 15 minutes, people start wandering, their minds starting to wander off, you know. But he said, if you ask a question every now and then, everybody will pay attention to what you're saying, because they're afraid if I ask you a question, you won't remember what I said. So I might ask you a question every now and then. But here today, we're to talk about a VNA, and this is the VNA. I'm going to donate this VNA and the computer to operate it with, and this is the VNA I'm going to use, and I've included all the adapters, so you'll have a, if you're connecting to a PL259 or a SO339, you'll have that B and C, and but this is a VNA. Now,
Excuse me, that's the, in your hand, that's the analyzer?
this is the analyzer.
Wow, we've come a long way. It's just-
Yes, it's kind of like the cell phone, you know, from a bag phone to this.
Is it software driven through the computer or?
Yes, you have to have a computer, or this can actually interface to your phone. Or I bought the phone's a little bit small. I bought a tablet today. It'll interface to that. I'll show you what it looks like when it's interfaced to that. But what I've done, let me get off of this so you can see the unplug that. Get back to the other screen here. Fix the desktop, so when you turn this computer on, it'll come up with all these presentations. And I wrote a little script on how to test these various things with the VNA. You can see that whether it's how to use it as a signal generator or whatever. I'm going to include a little manual that you can use to operate it. About it's I'm going to start the program, and it'll take a minute or two to recognize it.
While it's doing that, can I ask, how often do you recommend doing a test or check? Is it like routine maintenance, or just only when you think they've got a problem?
Well, if you're putting up a new antenna, or you're just curious as to where yours is working right, what does most amateurs use for testing antennas? What do they most primarily use?
Our little SWR meter on the radio?
Yeah, they usually use SWR meter of some type, right, that you put in line. And I'm going to show you today with a VNA what that meter in that line does to a reading that you check. What does the radio look for? Does it look for SWR, or does it look for impedance? Almost everything we use looks for an impedance of what? 50 ohms. And anytime you deviate from that, the radio will usually cut back on the amount of power. It's according to how far you've deviated from 50 ohms. I brought my manual for my HF rig, and this is the manual for it. What does it say that it will operate at?
1.5 to 1.
All right, it says without an antenna tuner, the antenna has to be 1.5 to 1 or less. So, and so this is the HF rig that I got. It's a fairly new rig. So 1.5 to 1 is not very much. John, you've been using one of my VNAs for a while. Is it pretty easy to use?
Pretty easy.
Your antenna have 1.5 or less across the band?
Well, when you and I tested it at G5RV, it wasn't resident on anything.
So really, on some radios, now, I have bought this radio with an antenna, it includes an antenna tuner, and so that will extend the range that I can use it. And I hate to call them antenna tuners. They don't tune an antenna. All they do is match whatever the impedance is to the radio, so you can get the maximum power out of it. I guess that you could call it an antenna tuner if it's actually connected to the antenna. Back in the 60s, I was teaching the 16 Collins 618T, which is used in the B-58. And that aircraft had an antenna that stuck right out the nose of the aircraft, and the tuner was attached directly to the antenna. So in that case, the tuner itself was part of the antenna, but most of the antennas that amateurs use sits next to their radio. So really, it's just tuning the feed line to your radio. It's not really, it doesn't change the antenna or anything. But so this is what the opening screen of this VNA looks like. And the club I think has a MFJ, don't they?
Yeah.
Now, the MFJ will do a lot of things that the VNA will do, but the VNA will sweep the whole frequency, where the MFJ, you can tune it to a certain frequency, but you can't tell what a lot of the things look like. I'm going to attach this to antenna here. Whoop. Adapter. Now what I've done, VNAs are extremely accurate. You can usually tell the accuracy of a meter or any device by the number of decimal point or decimals it looks at. Now what I've done with this particular setup, I've calibrated this to where I can come up here to calibration. And I've created files. And I've already calibrated for the SMA to N, SMA to SO2339. And if I'm just using SMA period, or if I'm using a B and C. So what I'm going to do, I'm going to come down here and select B and C. I'm going to say OK. Actually, it was already down here. You can see down here in the bottom, this is the calibration being used. I've also selected a frequency span. I've got all the frequencies here that are used in the amateur band. Right now I'm using 144 to 148. I'm using 2 meter band or 2 meter antenna, and I'm going to click on that, and I'm going to insert that frequency up there. And what it done, it swept this antenna Now, right now, I'm able to look at two different things, return loss and phase, and right now I'm gonna eliminate, I'm gonna say SWR.
Now, choose this antenna?
This antenna right here. This is the antenna I'm attached to right here. Now, in the engineering field, I had a lab that had thousands of dollars worth of equipment in it, but I did not have an SWR meter. I had return loss. Right now I'm looking at, you can see the return loss in the SWR. Green one is return loss, and the SWR is what we use or what you use in the amateur. What's SWR?
Standing wave ratio.
Voltage standing wave ratio, right? In other words, your SWR meter has a diode in it, and it picks up a voltage, and it compares that forward voltage to a reflected voltage. Return loss is about the same thing, except you're measuring power. It looks at the forward power and the reflected power. So they're kind of both the same. Whoop. All right, we're back to where we were. And this is notice that I'm strictly looking at SWR. Since we use SWR, I'm going to make this return loss an SWR2, or I can tell it none either way. But what I'm doing here, you can see over here on the left or on the right, you can see down here, anytime if I move my cursor across here, you can watch that right here is SWR reading. And as I move it across here, this antenna is 1.15 to 1 or to 2 right there, and it doesn't change very much. It's excellent. Now I can put markers on here. I can come over here and I can put a marker here. And so now it'll show up below. Marker 1 is at 145.0. You can see how accurate the frequency is on a VNA. And over to the right, you can see at that frequency, the SWR is what? 1.12. So I'm able to look at the complete response, or the worst case over here at the high end of the band. I'm going to put a marker there. At that end, the worst case is only 1.9. So this antenna is extremely good. When you're looking at antennas, one of the things they might talk about is the resonant frequency of the antenna. What's the resonant frequency of an antenna? How do you determine that?
By looking at your graph up there.
What really makes things confusing, and you get electronics, is resonant frequency occurs when there's no reactance involved. In other words, there's no capacitive reactance, there's no inductive reactance. And reactance is signified by X. So I'm going to find the resonant frequency just by finding where it says, I'm going to run this across here. It's easier for me to look at the computer.
Does X signify your X-axis on the graph?
No, X.
Right.
Everything's X to the L, X, see?
Whoop.
Capital X versus little x.
Okay.
Yeah. No,
All right, I got
it's actually the y-axis.
my reactance is 0. Now, VNAs also provide a Smith chart. Let me mark this at, let me put another marker here. Now I got 3 markers up there. I'm going to go over and look at the Smith chart.
If you were to test this at your home, would you hook it directly to the antenna, or would you connect it after it runs through your cable run, say, into your house?
You want to connect it directly, what's going to connect to your radio? Because I'm interested in what the radio sees.
Now, when you say that the SWR of an antenna tuner on a radio, usually it's just a diode to observe what the voltage is doing, does that mean that in order to be within the SWR window, that it would power down the transmitter on a radio?
If you didn't have an antenna tuner, most radios will protect themselves by reducing output power.
Okay, so you think you're doing good, but because of high SWR, your radio is powering?
I can make the radio put out its maximum power by making the radio think it sees 50 ohms.
Okay.
What you just showed us doesn't mean the resonant frequency is where the lowest SWR is, right?
Not necessarily, no. This antenna didn't show it the resonant frequency, and the lowest SWR occurred at the same place.
So is this typical of antennas that it does not occur simultaneously with the lowest SWR at residence?
As a general rule, the resonant frequency of the antenna does not occur. It can occur at the lowest SWR, but not always. They're usually fairly close. I have a little program on the computer that you can go to, and it'll explain what a Smith chart is. I've put 2 markers here. Everything above this line, this horizontal line, is inductive reactance. Everything below the horizontal line is capacitive reactance. I've got marker number 3, which was at the resonant frequency. See, did I mark 3 at the resonant frequency? Yes. You can look at this also shows you notice that the reactance here is 0. Up here, the reactance is 4 ohms. Down here, the reactance is 2. It is, looks like, I can't really tell what's in the way. I can look at the computer and tell, I can get a better picture. But 3 is marked the resonant frequency. There's another thing that occurs when you at the resonant frequency. That means their ohms is going to be the same. Let me go back to the chart. It'll be easier for you to see. The 3 marker is at the resonant frequency, and we can see there that it did not occur at the lowest SWR level. If I go down there and look at 3, the impedance Z and the R are both the same. Notice the resistance is the same in both places. In the electronic world, we have resistance, pure resistance, and we have imaginary resistance. If something is reactive, it's not, it's measured in resistance, but it's an imaginary resistance. It's not a true resistance. This is a resistance. This is an imaginary resistance. This is a true resistance. At the resonant frequency, both will be equal. If you're going to use this meter here, you want to find the resonant frequency of your antenna, you have to go to X and you adjust it until that X reads 0. So this meter will tell you what the resonant frequency of your antenna is. This meter right here will. You just have to keep adjusting it until you find the 0. This has 2 meters. This is the imaginary resistance meter. This one up here is the true resistance. So this resistance and this resistance is going to read different. Does everybody know that?
Could you expand on that a little bit more about what the difference is or why it reads difference? I'm not really following the concept of imaginary resistance.
They just started saying, you know, capacity reactance, they use resistance as a measure of capacity.
Right.
But it's not really a true resistance, it's an imaginary resistance.
Oh, okay.
Well, true resistance is an element that actually dissipates power,
Okay, right.
okay? Capacitive and inductive reactance actually are not a measure of power.
No, it's not.
They're a measure of the energy that's stored either across the plates of a capacitor or in the coils of an inductor. And what happens is that energy ultimately gets returned back into the circuit.
Right.
But it's not the same as what the heat generated by a resistor. But they had to come up with some way to derive the mathematics of how it all works. And so that's where they came up with imaginary resistance. Does that help out?
Somewhat. I mean, because I understand the basic physics, but in terms of describing the measuring of it, that's maybe what I'm not quite
Yeah.
there.
From your observations of using these meters and doing actual versus estimated SWR or reading, how critical or what's the percentage of error that my little, radio at my home with my SWR meter, I think I'm doing okay, and you've observed from doing real readings, is it significant enough of a percentage that we should invest the time to, go the extra step here and do a greater analyzing of my antenna system?
SWR meters, you're talking about high accurate SWR meters?
On the radio, I have one that's got a quote built-in antenna tuner, and I'm curious more than anything, is that,
How accurate is it?
yeah, and from your observations, you know, you've done this with multiple systems and that.
Most S-meter reading devices like we use and what's built into your radio, it has to do with how far you're away from the impedance. In other words, the meter is, as you move away from the true resistance the meter's made for, the less accurate it's going to be. You had an SWR meter that you built, didn't you, John? How accurate was it?
Well, it gets within a few hundredths of a percent within the true SWR. You know, based off the calibration of a 150 ohm or a 100 ohm resistor. On that particular analyzer I built, you don't want to use a 50 ohm resistor because the way it's designed, it messes up the meter, or it messes up the calibration.
Okay, so you had to use something
You
different.
have to use something either 100 or 150 ohm or a 33 ohm resistor.
I moved the radios on this one here. I'm going to do another sweep.
So is the answer like many things, it depends? I mean, just because you're talking accuracy, it's like, well, your source of accuracy wrong.
Doesn't look anything like it did before, does it? You can see up here now, it's the SWR has moved from low 1.1s to 1.9. Look at what happened to on the Smith chart. The antenna has all of a sudden become very, very inductive. And what happened to the resonant frequency? This is the resonant frequency point down there now.
Can you overlay those two charts?
Do what?
Can you overlay those two charts?
No.
Not the smooth charts, but the graphs.
You mean?
The original and this one?
Oh, no, I can't. I can't do that. I could if I was doing it on the computer. I could. I bought 3 different antennas here. Quarter wave, 5/8, and a dual band antenna. We get kind of fixed on resonant frequency. One of those antennas does not resonate at the amateur band. Which one would that be? No. The 5/8. The 5/8 is a non-resonant antenna. If I hook that antenna up to this DNA, do another sweep. If I run my cursor across here and I watch X, I can see that no place does X ever equal 0. Look at my Smith chart. This is the resonant frequency line here. This never crosses that line anyplace. But 5/8 antennas are used on a lot of vehicles, a lot of commercial vehicles. If you look at a police car, it'll have usually a Larson 5/8. What about the SWR? Worst case SWR is what? Let me move it away from the other antennas and see what it looks like.
It's not resonant frequency, why do they use that then? Is it just propagation?
It's fairly low. It's fairly low.
Okay.
Oh, it's swapped ends, didn't it? But even at the best end, I'm still what? 1.8.
So was that an effect of the other antennas that you have here?
Probably not. It doesn't have a ground plane. Let me see what moving it to there did. All right, this is the performance of this same antenna on top of my car.
Your car obviously has quite a bit of metal in it. Not-
Yeah.
Not like most of them.
Do what?
Not like most of them nowadays. Your car has quite a bit of metal, I can look at it.
Yes, it does. It has actually a ground plane.
Yeah, what's gonna happen when it's covered by
You won't see that dip.
You can see that the SWR is a lot better. It's still not as good as a quarter wave antenna with a good ground plane. Believe it or not, that 5/8 never is attached to the ground any place. In other words, your shield on your coax, this is a coil, and you can notice the coil is all plastic, and there's nothing connected but the center. this is a Browning, this is a metal, and it actually does attach to the car ground. I tested all three of these antennas on my car. This is the Browning. You can see, what's the difference you see on the Smith chart between the Smith chart of the, that's the Smith chart of the 5/8. No place does it ever see residence. This is the Smith chart of the Browning. It does have a resonant frequency. And the quarter wave antenna, this is a quarter wave antenna on top of my car roof. And you see it also has what? A resonant frequency. It crosses that horizontal line. Of course, the rooftop does not look like, my rooftop does not bend like this. So the SWR is actually pretty good though, isn't it? Look at here what they are, 1.4 at the worst case. Both ends 1.2, that's not bad. Roof of my car. What you're seeing is the ground plane is wiggling a little bit, so you're seeing all those ripples.
Why is it ripple?
It's moving.
Because the ground plane is part of the antenna, part of the. I'm back on the. You can see the longer it sets there, the cleaner this will be. Woo. Boy. Huh? When you're adjusting your antenna on your car, where do you need to do that at? Not next to your garage or someplace.
You're real close to the dual band antenna, kind of when it screwed.
Yeah, leave that one down right now.
It's wonder we ever get out of the car with our transmissions.
I can see that the worst case now with that flat like it is what? What's the worst case? I'm gonna add my SWR meter here to this scenario. All right, I'm gonna look at it again and see if that changed anything. Did change it, didn't it?
Is that considered a dramatic difference? I can't really see the top number there. Is that 1.8 something, or is it, what is 1.6 something?
For the building where you're on this, on that slope there, which frequency along the bottom that you're pressing it on?
Oh, I wasn't even paying attention to that, okay, I see.
So that's the frequency range of TV and amateur radio.
Sure, right.
So what I'm trying to do is see what it is approximately.
Oh, okay.
Changed the one end quite a bit. Actually, it made it better. What I wanted to illustrate there is when you put a meter in line with your antenna and you take it out, you've changed the length of the antenna line, and you can see that the antenna length is changing its resonant frequency. Actually, let's look at the Smith chart, see what it does to it.
Jerry, if you just substituted 20 feet of coax in there, would it?
Oh, it'd do the same thing. Anytime you change, that's why I say when you go to adjust your antenna, you need to use something that's measuring it at the, when I take it off the instrument and I'm measuring the width and I put it on the radio, I want the radio to see the same thing I measured. That's why
That's why you gotta measure right in front of the radio, not at the actual antenna.
Pardon?
That's why it's important to measure directly at the radio, not at the antenna.
Not at the antenna.
Because everything else is gonna affect the reading.
I don't think I'm sure, but you know, antenna height is also to affect music, up on the tower or close to the ground.
I want to measure it right at the antenna.
Okay, but can I,
I'm going to measure it right at what hooks to my radio.
okay, but if I'm trying to tune the antenna, shorten or lengthen the elements, is it doing good to measure it close to the ground, or has it got to be up on the tower? Or is it going to change significantly with antenna height?
It's going to change with antenna height too.
Up and down, up and down. This is the case where there's a need on the truck, there's the tower, leans over, so you can work on everything.
By changing my ground plane, I've also changed the resonant frequency. If I add cable to it, if I change the meter, I'm going to add the meter to it. Look at what happened to that antenna. Huh? It's all capacity now. Everything's below. There's nothing anywhere near the resonant frequency. Just by adding what?
From the amount of movement, about a quarter wavelength.
Huh? The SWR really didn't show me a whole lot of difference, did it? Go back to the Smith chart again. That's without the meter. So what that's telling you is if you use an SWR meter and you put it in line with your antenna line, it's not going to be the same when you take that meter out and hook it up to your radio. It will not.
Will the reading on the SWR have to be accurate? It won't be what the radio sees, because you have the radio back here and your meter and your antenna, but between here and the antenna will be accurate.
But I'm interested in what the radio sees.
Right, but I just want to understand that part.
Right. If I hook this to, if I'm in my shack and I hook it to my antenna, and I say, I want to know how long my feed line is. I'm gonna go over here and change that to feet. I'm going to say measure. All right. That tells me that the length of this cable right here is 12.4 feet. Pretty neat, huh? We went out and measured the length of that cable.
So, Terry, I have a question to ask you, but I don't want to take us off in a different direction. If, I'm going to go ahead and ask you, and this is not a good time to ask the question, so just, I'll just delay. But if we go out to the antenna, we climb up our tower and we hook right on to the people, and we take our MFJ and we find the exactly resonance for that antenna. That's important because that's what radiates. That's what allows it to radiate, having a proper, the length to be proper. If we go back down to the radio though and measure it, and the SWR is good, and it could be bad, but the radiator's still good.
You're talking about radiation efficiency.
Yes. Which is something that should be important to us.
That's radiation efficiency and resonance doesn't necessarily mean the same thing. This antenna right here actually resonates quite well, even though it's not resonant. The advantage of this antenna is its radiation pattern 5/8 antennas have a higher radiation angle. This quarter wave has a low radiation angle.
What does that matter at VHF since we're not talking long range propagation?
I'm talking VHF right now.
I know. But
If I'm talking to the repeater out here, and I'm close to the antenna, or fairly close to the repeater, this antenna will work better than this antenna. If I'm way far from the repeater, a lot of times this antenna will work better than this antenna because this antenna radiation will be going over the top of the tower or the top of the repeater. So if I'm wanting the best of both worlds, I can have two antennas on my car and switch back and forth and see which one picks up the best signal. If I'm way away from the tower or the repeater, that quarter wave will outperform the 5/8 because it's going to look at a lower angle, and as a curvature of the Earth, the farther away I get from the repeater, the lower and lower it's getting.
So, let's take my hypothetical question. I'm gonna go to my house, and as fat as I am, I'm gonna climb up on my antenna, and I'm gonna measure my resonant frequency, and I wanna cut my antenna accordingly, so that I know that at the feed point of the antenna, it resonates, that my efficiency would be right. Then I'm gonna go down to the radio, and I'm gonna measure it.
You're going to read something totally different.
Right, but there should be, I mean, we should care about that, and we should care about this, but only to the extent of not blowing our fouls.
But what you really want to do is connect the VNA to what's going to hook to your radio and go out and adjust the antenna to get the best performance, not at the antenna. No antenna provides exactly 50 ohms all the way across the band. So even though I went up and adjusted it at the antenna, there's only going to be one or two frequencies that I'm going to see 50 ohms. When you hook a 50 ohm cable to it, that's where things go bad, because once you change the impedance, the antenna impedance, it no longer matches the line. And so its impedance is going to change as you change in frequency. If I had an antenna that was 50 ohms all the way across, it wouldn't make any difference how long the feed line was. It would read the same.
Thank you, I appreciate you.
I'm interested in what the radio is going to see. And there's only a few instruments that will tell me that I can connect it to the line in the jack and tell what the impedance is at all the different frequencies. The VNA is one of those instruments. And it provides a lot of information to me.
Well, I think Jim has put on the actual key. If we're gonna check this device out and use it, we need to check you out too.
It's really once you use it for a while, John, can you use a VNA? You don't need me to operate the VNA.
Yeah, no. One thing that the VA will tell you, it may tell you that you have a good SWR, but if you look elsewhere in that information may tell you that you've got a high inductance load somewhere in the antenna, which basically impacts your radiating power. So let's say you may have a high inductance load, but a good SWR, let's say 1.5 to 1.5 to 1, or 1.1 to 1, but you got a high inductance, you may be losing 70–80% of the power going to that antenna because of the inductance. So if you're pushing 100 watts out of your transmitter, you might be actually getting 20, maybe 30 watts of broadcast power out of that because of the inductance.
Is that a big line problem, or is that an antenna problem?
Probably both. The G5RD antenna that everybody raves about, that it's a good, it has no resonant frequency. We looked at my antenna with the VNA, and you couldn't find any place on that antenna where it was resonant. It was all inductive, and you need the tuner to bring that inductance down and that resistance down in line that the transmitter will like.
Yeah, so you don't blow your.
So you don't blow your files. But at the same time, let's say I'm up in the 80 meter band, I'm losing about 70% of my power just because of inductance.
See how that brings up the point, there is an antenna that'll be 50 ohms from bottom to top, and it will be a perfect match every time. It's called a dummy load.
Yeah.
Yeah, but its radiation efficiency isn't very good.
Low radiation.
I want to thank Jerry for his presentation. I think